Hello everyone. Today I'm going to talk about the LeetCode problem, best time to buy and sell stock, which includes a series of problems, which is leveled easy to harder. So um, I will go through every question in this video. So thanks for watching. The first problem is a very basic case, best time to buy and sell stock. So first, let's go through the problem. Say you have an array for which the ith element is the price of a given stock on day I. So that means you are given a list of stock, and each stock has different prices. So you were only permitted to complete at most one transaction in this series of stocks. So the question is allowing you to design an algorithm to find the maximum profit. This is a very easy question, so we can use the intuitive idea that come in our mind to solve this question. So first we should determine what's the goal of this problem. The goal of this problem is to find the maximum profit. So the intuitive idea is obvious, is that you want to make sure the money you buy the stock is the minimum, and the money you sell and the slot you sell the stock will make you make the maximum money. So we can do a for loop through the prices through this array prices, such that we find the minimum number buy and the maximum number sell, and finally we can output the sell, which should be the maximum profit. So let's first write down the code. The idea is set buy as the default buying point 0, and the profit is scan the prices array. If prices I minus buy is larger, then we update profit. Otherwise, if the prices minus buy is less than less than before, otherwise we update buy. So let's write the code. First, the special case is that if the price is none, or price is the length is less than 2, then we just return 0, because in this case we even cannot buy and sell because we have only one prices. So we first say buy is 0 and set sell is 0. Sell is actually meaning the profit at the current slot. So our goal is to find what the maximum sale is. So we do the for loop for the sell prices array, and in each for loop we can find what's the minimum price to buy, and what's the maximum to sell. Actually, the sale is the profit because we are storing the maximum profit to the variable sale. So finally, you can return sale. Let's see the code. Okay, this is a very easy question. The second case is that still we are given an array of the prices, but in this case, you can complete as many transactions as possible as the previous question. However, you must not engage in multiple transactions at the same time. So that means you can the first difference of this problem is that you can make a lot of transactions instead of just one transaction as the previous question. And you also must sell the stock before you buy again. So that means, for example, you buy at I position, you cannot buy it again at the position I. And but you can sell one stock at I and then buy one at I. That's what's the meaning of you must sell the stock before you buy again. Excuse me. So let's see the example. You are given an array prices 7, 1, 5, 3, 6, 4. So you in this case you can buy at the day 2, which is at the price 1, and sell on day 3, you get a profit 4, and then buy on day 4 and sell on day 5, then you get profit 3. Then finally you totally get profit 7. So our goal of this question is to find what's the maximum number of profits after we do at most two transactions. This question is is not at most two transactions because you can do multiple transactions. So this is a kind of greedy method to solve this problem, because when we see you can complete as many transactions as you like, the intuitive idea should be comparing the neighbors of in the prices, and once the later prices is larger than the price at today is larger than the yesterday, then you can just add the difference of them, which means you can just buy at a lower price day and sell the price at a higher price day, such that the accumulated profits is the maximum. So this is also kind of immediate question. Again, we can consider special scenario, which means the price is less than 2, and we set profit as 0. So we scan the array prices. So if prices I minus prices I minus 1, which is larger than 0. That means the price at day I is larger than the price at day I minus 1. Then we just immediately add the difference to the profit so that we can get the maximum profit finally. Profit is equal to prices I minus price I minus 1. So that's we get our final solution. Yeah, that's basically another easy problem of this series of questions, but using different method, which is the greedy method. So let's skip to the third best time to buy and sell stock. Now the hardness level is coming to hard. Actually, I don't think this. Actually, a lot of questions can be done to solve this problem, and actually, one problem is very easy. No, I mean one answer should be very easy, but in general, people want to solve this question using dynamic programming. Actually, dynamic programming to solve this question is not the best solution, as I think, because dynamic programming uses quadratic space complexity or linear space complexity, so that this kind of problem is worse than the best solution in my mind. So what's the best solution in my mind? So let's first get to see the question. So right now you are still given a array of prices. However, in comparison, you can only complete at the most 2 transactions in this question. So right now that means you are given limitation of this problem, that you can only do 2 transactions instead of you can do transactions as many times as possible. So how do we do this problem? So let's first see the example. In the example 33500314. So what's if you are given this array, how can you do the max profit? Since in the question you have known how to get the max profit, the max profit is actually 4 minus 1 plus 3 minus 0. We can observe that this is actually equal to 4 minus 1 minus 3 minus 0. So that means we can do a kind of state transition of this problem, which means we can set buy 1 is 0 and sell 1 is 3 minus 0 and buy 2 is kind of 1 minus 3 minus 0 and the sell 2 is the final result as the 4 minus 1 minus 3 minus 0. That's the state transition function in this problem. Note that we can only do 2 transactions. That means we can buy 1 and sell 1 and buy 2 and sell 2, and no more transaction should be done. So the high level idea of this solution is that in order to get the maximum profit, cell one, we must make cell one as the relatively as possible to produce a small by two, and therefore by two can be as less as possible to give us the final maximum profit cell two. Actually, this idea is kind of like best time to buy and sell stock, number one. But right now we have transaction limitations. So let's see how to write the code. First we can set by one as an integer maximum value, and by two as the why we set it as a maximum value, because as we have said, we have to make by one and by two as minimum as possible. So we set the maximum value so that we can find the minimum number in the for loop. And we set cell one as 0 and cell 2 as 0. So we do a for loop for the prices array. So by one, this is similar to the best time to buy and sell stock one, but we need more transition. By one and sell one as the maximum value. So as we can see, the high level idea is shown here. So if we find the by one as small as possible, then we can get the sell one as larger as possible, because by one is smaller, then we can find the prices minus by one is larger. So this is a kind of a transition to the second transaction. We still find by two as a minimum number, and cell one and cell two as the by two. So that's basically the state transition from the first transaction to the second transaction for each slot I. So finally, we just return cell 2, which should be the maximum profit of the whole process. Let's start. Yeah. Actually, we need to consider edge case as prices as now, or prices length is equal to 0. So then we return 0. Yeah. That's the third question of best time to buy and sell stock. This is the best solution for this question, I think. A lot of solutions using dynamic programming to solve this problem. Actually, this is a special case of best time to buy and sell stock 4, because here we limit the transaction number as at most 2, but in the fourth question, we can the question asks a general case, we can do at most k transactions. So here is kind of the real question for me, because this question has included this time to buy and sell stock number 3. So let's take a look at the fourth question. So after seeing this question, the only difference is that we now have at most k transactions. A very basic solution is that how can you can also you can immediately translate the method we used in the number 3 question, that we can do the process k times such that we find the final solution. This is very easy to translate. There are still two differences. Basically, there are two differences of this question between 3 and IV, but the high-level idea is the same. The first is that if k is larger than or equal to process length, then this problem will be equal to best time to buy and sell stock 2, because if k is larger than the half of the process length, then this question is kind of equal to we can do multiple transactions. The second difference is that we need to we used state transition 2 times, but in this question do it k times. That's basically the two differences of this question. So let's see how to write the code. So first, we still write down the edge case. Return 0. So we consider the case k is larger than or equal to process length, half of the process length. And in this case, we can just do as the best time to buy and sell stock number 2. We set a profit variable and do the for loop for the prices array. And if prices of this day is larger than the previous day, you get the profit plus SSI minus 1. And finally you return profit. So that's basically the first difference of this question than number 3. So right now you have we are going through to the state transition process for the prices such that we find the maximum profit. So in the previous case, we can just set buy 1, buy 2, and sell 1, sell 2. But in this case, we have at the most k transactions. We set buy as an array which has k plus 1 numbers, and also we have sell as an array of k plus 1. a plus 1 array. This is because we can do the transition from the first transaction to the case transaction such that we can find the largest profit. So we do the for loop as before for each price. And starting from k is equal to 1 and until I is equal to k and I plus plus. Then we can do kind of a similar transition from buy 1 to sell 1, which is buy I is equal to minimum buy I price minus sell I minus 1. And sell I is the maximum number of sell I to price minus buy I. So finally we return sell k as the final solution. Oh, there's a problem. Can't find the thing. Okay. Omit s. So problem here. Perfect. This is might be this. No. Let's see how to find the problem. Oh, here is the problem. I forgot. We should set the first state of each buy as the minimum number. Oh, sorry, the maximum number. So let's see the problem. I think right now it should be correct. Yeah. So sorry, I forgot this step. We should first set the buy as the maximum value. So in the first loop, we can find the minimum number as the price minus sell I minus 1. So that's the one solution of this problem. I think this is the best solution I have ever seen because the time complexity of this problem is linear. time, and the space complexity is also linear. So the most general solution of this problem is using dynamic programming. Actually, if we use the dynamic programming, the second part should be different, but the first part is the same, because in general, if the k is larger or equal to the process length, half of the process length, then we can just return the profit. But if we using dynamic programming, we need to come up with a DP solution. The DP solution of this question is we will set a two-dimensional array as a dpij. dpij means where I will be denoted as the total number of transactions, and j is number of days, and the dpij stores the max profit at day j after I transactions. So there are two cases basically. The first case is that if no transaction at day j, we can just set dpij as dpij minus 1. This is easy to see because if we don't do transaction at day j, we can the maximum profit of day j is equal to that one at the day j minus 1. So the second special case is that if having transaction at the day j, so dpij should be equal to the maximum profit at some point m. That means at some day m, and the last transaction I minus 1, and plus the prices difference at j minus prices m, where m is in the range of 0 to j minus 1. That's the dynamic programming solution. So let's see how to write the code. Actually, the first part is the same as we mentioned. So right now the difference is that we have to open a two-dimension dynamic programming array as dp, as the row number should be k minus 1 per k plus 1, and the row length should be the prices length, the array's length. So according to the dp array, we do a two-dimension for loop actually. Max difference then we calculate dpij according to the dp solution, which is dpij equal to max j plus max diff max diff is in order to find what's the maximum number of prices j to some day m. That means the price is j minus price is m. And here should be I minus 1 j minus price is j. So this kind of more complicated than the easiest solution, I think. Finally, we should return the last position of the DP array. So DP 0 length minus 1. So that should be the final solution. Even though the time complexity, the time we use is similar to the previous method, but in theoretical complexity, we find it uses n square space in this question, and there are also n square time complexity in the outer loop and inner loop. So should be n square time. So that's the two methods to solve this question, but I think the first answer I used is the most easiest one. So that's all for today. Thank you for watching.